Okay, moving on to section 2. This one is called the case of the missing diagram. Okay, so in this section, what we're going to be doing here is we are going to be given some information like this. A couple sentences. And what we're going to be asked to do is draw a diagram that matches what they're saying in the couple sentences or in the sentence. And then they're going to be asking you to provide a given and a prove, and sometimes, in some cases, they're going to be asked to prove it. So basically, you're going to be given some sentences and you're going to be asked to come up with an actual proof based off those sentences. So, two circles intersect at 2 points. All right, two circles intersect at 2 points. So I'm going to draw the diagram. I got a couple circles here. There's one. There's another circle. And they intersect at 2 points. So those 2 points would be right here and right here. The next part of it says the segment joining the centers of the circles. Well, segment joining the centers of the circles. That would be this segment right there. Bisects the segment joining the points of intersection. Okay, the points of intersection we talked about were these 2 points. And we're talking about a segment joining those points of intersection. So in green, here's the segment joining those points of intersection. Okay, I'm going to go ahead and label some of the letters on the diagram. So this would be A, B, C, and D, something like that. Perhaps I'll label that E right there. I'm going to provide a given and a proof. So the givens are that you have two circles. Okay, you have circle A and circle B. And what you're trying to prove here is that the segment joining the centers of the circles bisects the segment joining the points of intersection. So the segment joining the centers of the circles, that's AB, bisects the segment that joins the points of intersection, CD right there. Okay, and that would be what you're expected to do. You could take it a step further, obviously, or many steps further, and write a 2-column proof based off of that, and prove that if we can prove that, then it would always be the case. So let's try a few more of these. There's another one down at the bottom here. So it says the median to the base of an isosceles triangle is also the altitude. So this goes all the way back to we were doing hypothesis and conclusion. We were writing if-then statements. So the if part of it is if you have a median, then if you have a median drawn to the base of an isosceles triangle, this is the if part. The then part is then it's an altitude. Okay, so the if part is the part that's given, and the then part is the part you're trying to prove. But let's draw a diagram first. So you have an isosceles triangle, A, B, C, and the median to the base of an isosceles triangle. So let's draw in a median. Is also the altitude. Okay, so let's do some givens here. The given is that AD is the median to BC. And you also have triangle ABC is isosceles, and it's with the base being DC. Prove, by the way, whenever we do tests and quizzes, students always forget this part. Make sure you indicate where the base is when you're doing an isosceles triangle. Okay, that's a side note. You want to prove now that AD is an altitude to BC. Okay, and then what we would do is, we can actually draw a 2-column here, and we can do the actual proof. Okay, I'm not going to do the proof for now. Okay, let's jump to the backside. Let's see if there's any on the backside that we want to try. Okay, we're moving on to the backside right now, and what I want to do is actually go over one problem. That's problem number 3 here on the backside. And basically, number 3 starts out by saying the if part, so that's your given part, and then the second part is the then part. So if 4 sides of a 4-sided figure are congruent, so let's draw this out. 4-sided figure, all 4 sides are congruent to each other. Label it A, B, C, D. So the given part of that is that AB is congruent to BC, which is congruent to DC, which is congruent to AD. The proof part of this is you want to prove that the segments connecting the opposite vertices, so an opposite vertex or opposite vertices from each other would be these two. Okay? The segments, so it's plural, connecting opposite vertices. So there's another set of opposite vertices right here. And you want to prove that they're perpendicular. So you want to prove that AC is perpendicular to BD like this. And then normally, depending on the type of problem, I would ask you to write the 2-column proof out. Look for the instructions on your homework, and you can decide, or you can write the proof out if you need to. Okay, hopefully that helps, and I'll give you a chance to get started. All right, take care.